ratio is and where they come from, sine, cosine, and tangent when using right triangles. But in order to talk about that, we need to make sure we're familiar with a few concepts that we've studied in the past. One of the first ideas is, what is a ratio? Because we're talking about a trig ratio. So when I say tangent of x equals 1 over 2, the 1 over 2 is a ratio, or a comparison. So a ratio is a comparison of two things. And so what are we comparing with tangent? We're comparing what's the opposite side compared to the adjacent side. So this one is saying that the opposite side, for every 1, there are 2 in the adjacent side. So we'll get more into that. Comparisons can be written this way, 1 to 2. We can make a ratio like this, 1 to 2. Even a division problem is a comparison or ratio, even though it is also something you can divide. But I mean, a fraction is also division. So these are all saying basically the same thing. For every 1 of something, you have 2 of the other. For every 1 boy, you have 2 girls. For every 1 cake, you split it into 2 pieces. Another thing to keep in mind are decimals. So decimals are also percentages when we look at them that way. 1/2 as a decimal is 0.5. Well, how do we turn that into a percentage? We had learned that we moved the decimal spot twice, because percentage, like in Spanish, is por ciento. Por means out of, and ciento means 100. Out of 100. So we're going to take a decimal of 0.5 and make it out of 100, and that would be 50%. So well, actually to begin with, what's 100%? 1.0. Because if I move the decimal spot twice, I get 100%. If I go above 1, like 1.24, it still works. Move the decimal, it's 124%. Sometimes you have a larger than whole number, larger than 1. 0.99 would be 99%. You move the decimal spot twice. 0.04, we move it twice, would be 4%. Don't be fooled when there's a 0.3, let's say. Even though there's no 0 there, it's really 30. When we add the two decimal places, we add that 0. So 30%. This will help us to understand that the decimals we're getting are really percentages of one side compared to the other side. So one way to look at trig ratios is to look at something we're familiar with. We were taught about 45, 45, 90 and 30, 60, 90 triangles. So 45, 90 triangle has these characteristics where it's isosceles, meaning there are two angles and sides that are congruent. That's what these markings here are. These two sides are congruent, which is it's basically equal for shapes, and the two angles. And so since every triangle makes 180 degree, here's 90, these two must be 45 and 45 in order to add up to the sum of 180. So what we learned about this 45, 45, 90 is that it has a ratio of 1, 1, radical 2. And you can use the Pythagorean theorem to get that. 1 squared plus 1 squared equals square root of 2 squared. And I want to focus just on the two easy numbers. So let's assume or pretend that we use angle C as our reference angle. We're going to set up a trig ratio, and we're going to use tangent because when I label it, my hypotenuse is blank, my opposite is here, opposite of the reference, and my adjacent is right here. So tangent, opposite and adjacent, that's another lesson in case you've forgotten. We use so, ka, or toa to help us remember our ratios, and the o and the a is using tangent. So tangent at the angle 45 degrees, we know for a fact, we're positive, is 1 over 1. or 1. When we move the decimal over and turn it into a percent, we're saying 100%. So at 45 degrees, the opposite will always be 100% of the adjacent. And knowing this, we can use this information for future triangles to understand either a missing side or a missing angle. For example, ooh, that's not a nice triangle. If you take another 45, 45, 90 triangle, and again you have x, well, might as well leave them in the same position so we don't have to second guess our labeling. So let's pretend it's 33 and 33. When I label this, it's the same, opposite and adjacent. So tangent of x is 33 over 33. Now, isn't the opposite side green 100% of the blue side? And it is, right? 1 or 100% when we turn it into a percent. So 1.0 is 100%. So anytime you have the two sides 100% of each other, the opposite and the adjacent sides, we know x must be sitting at 45 degrees. So we've now created a rule that we can put on a chart and have as a reference. And we can do that for any triangle that has opposite and adjacent with the same sides, no matter how big the numbers or smaller numbers are. Because all similar triangles that are bigger or smaller with 45 degrees will have a 100% ratio of the green side divided by the blue side. So in the old days, we didn't have a calculator. Now that we do, right, we could say 1, and we're looking for an angle, so we use second tangent. That's another lesson. And we have 45 degrees. So it's a rule that we've programmed into our calculator. Before then, we used a chart. So this is called a trig ratio chart. And this is what we used before scientific calculators. And when I was in school, scientific calculators were much more expensive, and we didn't have cell phones, so you didn't have a calculator in your pocket every day. We're going to look at tangent, and we're going to say on the very bottom, it's at 100%. Well, we move to the left and see exactly what we just determined, that at tangent 45 degrees, we always have the opposite as 100% of the adjacent side. So what we did is we calculated this ratio of the opposite divided by the adjacent for tangent, and we did it for every single degree. Now this stops at 45, but it keeps going all the way up to 89.9 or 90 degrees. So let's take a look and see if we can understand what we're saying here on this chart. Let's say I have another triangle, another right triangle. And I want to find the angle x. And my opposite side is 30. And my adjacent side is 100. So again, we have these already labeled in the same order. That's the opposite, that's the adjacent, that's the hypotenuse. So tangent at the angle x is going to be 30 over 100, which is 0.3. So what this is saying is that the opposite side, pink, is 30% of the adjacent side. So we want to know what degree gives you 30% of the opposite for whatever the adjacent is. So we'll look at the tangent chart and we'll look for the closest one to 0.30, which is right here. So we'll move to the left and see that that is at 17 degrees. And that's what your calculator is going to come up with. See, if we put 0.3 and we use inverse tangent, we get 16.699, which rounded to the nearest whole degree is 17 degrees. We're going to study something in the future called the unit circle. And so if you imagine taking a circle, and we know that the entire circle around is 360 degrees. If we begin to cut it, we cut it first and we have 180. So we have a straight line. We learned in geometry that a straight angle is 180 degrees. When we then repeat that and cut it in half again, we have 90 degrees. So if we focused here on this corner, we can find 1 degree and make a triangle. And I mean, this pen is too thick to be able to accurately do every degree. But what we can do here is use this circle to find every degree and make a triangle. So that's part of what we did in the past, is we found 1 degree, 2 degree, 3 degree, 4 degree. And in doing this, we compared the sides. So if we took a unit circle, maybe draw another one. And in the future, you'll be changing the degrees into pi, because we learned that all the way around a circle is 2 pi r. So we're going to use 0 and go all the way around and call it 2 pi. But that's another lesson I can make, but it's something you will study in trigonometry more. So the unit circle we have here, or the circle we have here, I'm going to cut it in half. And now I'm going to make a triangle out of it. So if I take, let me take a line. Well, let me see if I could change the color. If I try to make a triangle and let me erase that. I'm going to go as accurately to the center as I can because it doesn't have it marked. And I'm going to go here. I might have 1 degree, 2 degree, 3 degree, 4 degree, and we can go all the way around and make triangles out of it. So I can make a triangle here, and let's pretend it's, I'm going to have to estimate. Let's pretend it's something like 18 degrees. So the way I would find tangent of 18 degrees is I would compare this red line and I would divide it by the bottom, the adjacent side, the bottom of the triangle, the black side. And I would then get a decimal of what percentage is this red one compared to the black line. We can then use our chart. So at 18 degrees, we know it would be right here, 32.49. Changing it to a percentage, we have 32.49%. So what this is saying is that the red line is 32% of the black line. So if I had that triangle here and I use some easy numbers, if this was 32, we know this had to be 100 because this would make it 32% of the adjacent side. So a trig ratio is really comparing one side to the other side. We did the same thing for sine and we did the same thing for cosine. A similar thing would be for a 30, 60, 90 triangle. We had learned that this side is 1 and that the hypotenuse is always double the small side. So this is the opposite side if I'm standing at the 30-degree angles as a reference. And I'm going to use sine, opposite and hypotenuse, the O and the H. Sine of 30 degrees is, for every one of the opposites, the hypotenuse must be 2, or 50%. So again, what we're saying is the opposite side in a 30-degree right triangle is always 50% of the hypotenuse, or this red side right here. So the green side is half, 50% of the red side. When we look at our chart, that's exactly what we see. So if I go up here, I have sine right here, and I have 30 degrees, it's always half. So we now know that as a rule, whenever I have 1 to 2 or 50% of my opposite side compared to my hypotenuse, or if my opposite side is 50%, then it's going to make 30 degrees. So we can even make an example here. Get a new page. And this will sort of be the last example. So here's an x. And let's say this is 125 and this is 250. That's my opposite. That's my hypotenuse. So you might say, okay, the missing angle, not tangent, we're using sine, SOHCAHTOA. So the opposite and the hypotenuse are using sine 125 out of 250 is 0.5. Well, we just finished talking about that. X must be a 30-degree angle. So what we're really saying in a trig ratio is in any similar triangle, like this could be a 1 to 2, like we said, it could be a 50 to 100, right? These are similar by angle. And what we could do, again, is if we have sine of x equals opposite over hypotenuse is 0.5, 50%. So, again, the angle must be 30 degrees. So one thing that we might have done in the old days is we might have taken a really, really large circle. You know, the bigger it is, the easier it is to measure. So let's say we make it 100 feet. And using that, we could measure each side and make a comparison. And so that's kind of what they did here on this unit circle. The green line and the red line and the black line, the opposite, adjacent, and hypotenuse. And so as we get into higher math, we're not only going to go to 90 degrees, we're going to keep going past 90. We're going to go to 180, we're going to go to 270, 360. So in geometry, we tend to focus on 30 degrees, but really we can make more than 30 degrees. We can keep making the angle larger and larger to 180, and then even we can look at it as larger than 180. So over time, we created these charts and we programmed our calculator to know all the comparisons. What percentage of this side, the opposite, is it when we compare it to the hypotenuse? And it'll give you the degree. So this allows us to solve for a missing angle when we have two sides. It allows us to find a missing side when we have an angle and one side. So it allows us to solve a lot of things with triangles. And triangles are the beginning of most geometric shapes, because if you take the geometric shapes of the ones we're familiar with, you take a square, well, we can cut it into triangles. If you take even, an octagon, we can cut it into triangles as well. So understanding triangles would actually help us to understand all regular geometric shapes. And so it's been fundamental to understand the triangle as we built our knowledge in understanding shapes in the world around us and how they work and how to make measurements and create architecture and design. So I'm not sure if it's too clear. I could redo a video based on some feedback and questions, but that's the basic idea of what a trig ratio is. So to me, it's kind of neat or interesting that when we go back to that ratio, when we really think about it, a triangle is really trying to understand one spot on a circle. So if we stop this at one point, we can take in and extract a triangle out of it. So it's interesting to me that sine, cosine, and tangent are right triangles, and each of those right triangles represent one spot on 1 degree of this unit circle. And if we were to graph, that's another lesson, but to me it's just fascinating. If we were to graph each of these points on a regular coordinate, that's when we're going to get into something called waves. So going back here, you can see if we start to graph them, and again, it needs explaining. Graphing all of the right triangles around a unit circle will create the sine and cosine waves. And this is going to allow you to program things to do sound waves, color waves, energy waves in physics. And it really becomes an integral part of understanding science and the world around us. So sine, cosine, and tangent, while it's triangles at this point, eventually it leads to understanding the unit circle and waves and things that will allow you to basically explain things we couldn't explain before, like physics and color waves and sound waves. And what waves really are a language. It's just like notes, music notes, or English or Spanish. And the wave can explain things and help you to understand past events and predict and create future events, depending on what you want to use it for and what area. So trig ratios are pretty important, and I hope you understand a little bit more about what they